We spent a while talking about electric fields. Now it's time to get into magnetism. So first, magnetic fields. If there are such things as electric fields, there are such things as magnetic fields. They work in some ways we really try intuitively to make them just like electric fields. And they have some similarities, but not many, honestly. So magnetic field is a field, meaning it's going to be able to put some kind of a force on an object without coming into contact with it. It acts at a distance. Our electric field had units of newtons per coulomb. Our magnetic field has units of Tesla, capital T. A Tesla is a pretty strong field. We're not usually talking about full numbers of Tesla. Electric field was a vector. Magnetic field is also a vector. Give it a letter B because we use M for mass and we've got to have some letter, right? So electric field, magnetic field. In an electric field, if we stick a positive charge here, we get a force that is parallel to the electric field. In a magnetic field, if we have a magnetic field and then we have a positive charge that's just sitting here, we get a force of 0. If we make that force, or if we make that charge start to move in certain directions, we will get a force that's perpendicular to the magnetic field. We'll talk about just how that happens and what that's about later. With an electric field, we can have a positive charge and it will put out electric fields around itself. We can have a negative charge and it will bring in electric fields from around itself. With magnetic field, we don't have a single source of magnetic field. We don't have a single sink of magnetic field. What we do have is a magnetic dipole. Magnetic field lines will come out of the north pole of a magnet and go into the south pole of a magnet. Now you might be thinking, that means a north sure seems like a positive and a south sure seems like a negative. But it's not quite the same. First, these loop around. That's one thing. So a magnetic field will form closed loops, where an electric field has a start and a stop. Now it might be out infinitely far away, but it means it's not coming back around and closing on itself. If I take this magnet and I cut it, I would have a south end like this, a north end like this. So let's say I move that north end far enough away to where these don't really interact with each other. That south end, the left side of it, nothing happened there. And I've already found that those loops close, which means there must be a loop coming out of here. And inside the magnet, we connect the south to the north. So what I've done by cutting this thing in half is just made two smaller magnets. Those are some of the differences between electric and magnetic fields. We'll get into a lot more of them as we go. For right now, that's a good place to start.